हेलो एंड वेलकम गाइस। आपका स्वागत है एलिविएट लैब्स की कोड शेफ सीरीज़ के अंदर। तो आज भी हम दो प्रॉब्लम्स लेके आए हैं आपके लिए। और बेसिकली हम एक एक करके ये दोनों प्रॉब्लम्स को सॉल्व करने की कोशिश करेंगे। तो जैसा कि हमने चार प्रॉब्लम्स स्टार्ट की थी, तो हमने स्टार्ट किया था 1100 से, फिर 1200, देन 1500। तो राइट नाउ वी हैव सेट अ बार की बेसिकली वी विल स्टार्ट सॉल्विंग दी problems from 1500 onwards. So there are two problems that we will solve today, and one of the problem is minimum number of pizzas. The code is MINPIZZAS over CodeChef. You can find the problem link in the description when you are actually watching this video, and I would recommend you sitting with me having a laptop and pen and paper, uh, because when we are actually trying to solve a problem, we want to solve a problem uh, to its best, right? And basically we want to put our brains to it. ऐसा नहीं करना है कि बेसिकली केवल वीडियोस को वॉच करना है और हमें सॉल्यूशन एकदम से ही समझ में आ जाएगा सारा। धीरे धीरे बेसिकली ये जो थिंकिंग है कि कैसे हमें प्रॉब्लम को सॉल्व करना है, वो करने से ही मालूम पड़ेगी। सो लेट्स नॉट वेस्ट एनी मोर टाइम एंड गेट बैक टू द प्रॉब्लम। ओके, तो पहले प्रॉब्लम को रीड करना स्टार्ट करते हैं। ओके, so minimum number of pizzas. So chef is throwing a party for his 10 friends, and there is a pizza store nearby, and he wants to buy a pizza for his friends. Each pizza has exactly 8 slices, and chef friends get sad if one gets more slices than the other. Okay, so he wants to distribute slices evenly among his 10 friends. Also chef gets sad if there are some pizza slices left. So basically whatever the pizzas are there, it should be completed. Basically there should not be any leftovers, right? So more formally, suppose chef buys p pizzas, then everyone is happy if and only if there is a way to distribute k dot p slices between n friends. Okay, so okay, you need to find minimum number of pizzas chef has to buy to share all the slices among his friends so that none of his friend gets sad. And note, the chef hates pizza and does not take any slices. So basically he is going to order the p pizzas, and we want to find out this value p such that all his friend gets pizzas, all his friend gets equal amount of slices. Okay, and there is no slices that is left after his friend has ate. Okay, so first line of input contains t, the number of test cases. Okay, and each test case contains two separate integers n and k, where n is the number of friends of chef and k is the number of slices in the pizza. Okay, and for each test case, print the minimum number of pizzas chef has to buy to share among his friends so that none of his friends get sad. Okay, so looking at this is the problem looks quite simple. Basically he has given us the number of friends, he has given us the k slices, okay, that each pizza has, and basically we want to find out the pizzas such that basically all the pizzas get ate by all these n friends, and basically all of them gets equal number of slices. Okay, so the value of t range from 1 to 2 to the power 10 to the power 5, and value of n of k, n and k ranges from 1 to 10 to the power 9, which is okay. And there is only one sort of a task, which is 100 points. So basically there is no sort of distribution of partial scoring here. Okay, and basically if you look at the sample test case, so let's look at this one, 2,3. So basically one pizza has 3 slices, okay, and there are 2 friends. So basically if you want to distribute these 3 slices to 2 friends, you cannot, because they at least one of them will have one more pizza, and that is because of pigeonhole principle. And if you are going to distribute, let's say, so at least you will need to have 2 pizzas, so that basically you have 6 slices, and then you can distribute 3 slices to one and 3 slices to other, so that all of them will have equal pizzas and there will be no leftovers, right? So that's the explanation that he has given. And in the more info, basically we have a limit of 0.5 second. So as you can see, जब अपन ने लास्ट बार चेक किया था तो अपने TLEs आ रहे थे, राइट? तो यहाँ पर अपना बिल्कुल सिंपल है कि अगर अपन ने एक भी n या k या फिर t का एक लूप लगा दिया, t का लूप तो लगाना बिल्कुल जायज़ है, राइट? बिकॉज t का तो लूप आपको लगाना ही पड़ेगा, दैट यू कैन नॉट अवॉइड, राइट? यू हैव टू एक्चुअली टेक ऑल दोज टेस्ट केसेस एज एन इनपुट. सो t का लूप एक आएगा ही आएगा, बट यू कैन नॉट हैव एन n और k लूप, राइट? तो अगर अपन बात करें तो यहाँ पर सबसे पहली चीज़ जो आ रही है वो ये आ रही है कि बेसिकली हमें एक मिनिमम नंबर ऑफ़ स्लाइसेस निकालने हैं, राइट? मिनिमम नंबर ऑफ़ स्लाइसेस निकालने हैं. मिनिमम नंबर ऑफ पिज़्ज़ास निकालने हैं सच दैट वी कैन डिस्ट्रीब्यूट इवनली, राइट. तो अगर मैं 6 की बात करूँ, राइट, 6 की बात करूँ, 6 इज और 2 पिज़्ज़ास की बात करूँ तो 2 पिज़्ज़ास में 6 स्लाइसेस होते हैं. सो इफ़ यू लुक एट 6 इज़ डिविजिबल बाई 3 एंड 2. सिमिलरली अगर मैं 4 फ्रेंड्स हैं और एक पिज़्ज़ा में 2 स्लाइसेस हैं तो आई विल नीड 2 पिज़्ज़ास एंड दोज 2 पिज़्ज़ास विल हैव 4 स्लाइसेस. सो इन टर्म्स ऑफ स्लाइसेस, अगर मैं केवल स्लाइसेस की बात करूँ तो जो स्लाइसेस होंगे वो आपके एक पिज़्ज़ा के जो स्लाइसेस हैं उससे भी बेसिकली आपके डिवाइड होंगे और जो नंबर ऑफ फ्रेंड्स है उससे भी डिवाइड होंगे. सो बेसिकली वेयर आई एम गेटिंग एट इज लोएस्ट कॉमन मल्टीपल. सो व्हाट इज़ लोएस्ट कॉमन मल्टीपल, राइट? If someone does not know, you can check over Wikipedia. Lowest common multiple, right? So LCM is basically defined as the smallest common multiple of two integers a and b, usually denoted by LCM of a comma b is the smallest positive integer that is divisible by both a and b. So smallest positive integer that is divisible by 2 and 3 is 6, okay, and if you divide 6 with 3, that will be your number of pizzas, because one pizza has 3 slices and you have 6 slices, so how many pizzas you will have? 6 by 3, which is 2. Similarly, one pizza has 2 slices and you have 4 slices here, so in that case basically how many pizzas you will have? 4 by 2, 2. Similarly, in the first case you have 2 slices, right? One pizza which has 2 slices and 2 friends, so basically you only need 2 slices to equally distribute them, and how many pizza you would require? 2 by 2, which is 1, right? And that is your output. So what we need to find out is LCM. But what are the ways to find out the LCM is? So one way to find out, given a 2 number, so let me just first write down the very basic sort of an implementation for LCM. Then we will look how to optimize it. I shouldn't have said that, but okay. So while t minus minus, now basically we will take our n and k and we will take the input. Yeah, so now what we will do is we will start a loop from 1, or let's start from minimum of n comma k, whatever is minimum, and basically we will go till n times k I plus plus, and what we are trying to find? We are trying to find whether there is an I which is basically divisible by both n and I and k. So basically what we want is n mod I is double equals to 0 and k mod I is double equals to 0. That means that, sorry, my bad, I mod n is double equals to 0 because n would divide I and k would also divide I. So basically what we are trying to do here is we are trying to find the lowest common multiple, okay, of n and k, okay, and such an I is found, then we will break, and basically our answer will be the number of slices in a pizza is k, so basically we want I divided by k, and that is our output. So if we start this, if we run this, so basically we are getting 1 to 2, but as I already pointed you out that this is 10 to the power 9, right? So as you can see, this loop can go till 10 to the power 18 times 10 to the power 5, so basically 10 to the power 13. Basically it might take almost 10 to the power 9 iterations to actually figure out a multiple, right? You are given 2 prime numbers, so basically the multiple of those 2 prime numbers can be huge, right? In that case you will have to go till that number, iterate over that number. Basically if you take 2 and 3, these are the prime numbers, right? So the multiplication of them is 2 times 3, which is 6. So basically you have to at least go 2 or 3 iterations, at least you have to go 3 iterations to reach 6, and that's what the idea is, that basically if n and k both are the prime numbers and they are like, let's say, of the order of 10 to the power 5, then their multiple will be in 10 to the power 10. So you will actually reach, when you will try to reach it there, you might fail, right? And it might give you TLE. So let's submit it anyway, but we know that this is going to give us TLE. So this is a very brute force approach to find the LCM, right? And that's not going to work. So as you can see, the time limit is exceeded. Only one of the tasks got cleared, but rest of the tasks did not. So now how do we solve it better way, right? So there is an algorithm for GCD, which is Euclid's GCD algorithm. So you might want to look it over Wikipedia, and that's a very finest algorithm. So you might be confused like why I am trying to find GCD, okay, for with Euclid's algorithm, right? Why I am trying to go there. So basically Euclid's algorithm of GCD, given a GCD of two numbers, and those two numbers you can figure out an LCM via this simple equation that basically your LCM is nothing but A times B divided by their GCD of A comma B. So this is a simple mathematics of roughly 9th and 10th class, that basically LCM and GCD are the multiple of those two numbers. So if you multiply GCD with the LCM of A comma B, then basically you will get A times B, right? So LCM times GCD is equals to A times B. So what we try to find out is, if we know GCD of A comma B, and if we know the GCD of A comma B very fast, then basically what we can do is we can calculate LCM as fast as GCD. So that's what the idea is. So what we will try to do is we will try to use this Euclidean algorithm for finding out the GCD, and it's known for its time complexity. It almost takes log b amount of time, log A or log B, whatever is bigger. So basically it takes that much amount of time to reach the to figure out the GCD. So the idea comes from very simple equation, is that GCD of A comma B. So the idea of Euclid algorithm is that GCD of A comma B is nothing but GCD of B comma A mod B, right? So that is what we are going to use. Okay, this is a recurrence, and this is basically what this Euclidean algorithm actually try to enforce upon, right? So the algorithm goes as follows: GCD of int A, GCD of int B. If B is double equals to 0, we will return A. Otherwise we will return GCD of B comma A mod B. Okay, so that is as simple as that. And here as well, if you look at this pseudo code, this is basically given you on Wikipedia. If B is 0, then return A, and if GCD, otherwise GCD of B comma A mod B. So this is basically a very simplest thing. And since you are dividing the number A and you are taking the remaining bits, so whatever the value in A will be, that will be less than the number of the bits in A will be less than or equals to the bits in B, right? So basically you are dividing it with the number B, correct? So you are not going to get, you are actually trying to make the second argument as small as you can, okay? And in log n step you will actually reach 0. Okay, so that's what the idea is. In log B steps you will actually reach 0. So that's what the idea is. Okay, so you can look over it, you can check out its how basically this works in logarithmic time. All the things are given on this Wikipedia link, which I will share in the description below. Okay, so now we have this GCD function, which is a very nice looking function. Now we can get rid of this loop to figure out the LCM. So our LCM would be nothing but n times k divided by the GCD. So that is the GCD of n comma k. Okay, see out LCM and L. Okay, now let's run this. So we have the LCM correct, but our answer is LCM divided by k. Now we submit it. So do you think that it will give us the correct answer? Let's wait. No, it didn't. So those who thought that it would give us the correct answer, no, you are wrong. And if you really want to find out why, so here is a time to think about this code, think about the constraints, think about the code, and check why this is giving the wrong answer. Okay, although the approach is very similar, because earlier as well we tried to find LCM and basically we divided it by k, but here we are trying to find LCM and basically dividing it by k, but why it is not working? So for those who really want to solve this debugging problem, here is the time, pause the video, take your time, take pen and paper, and basically check what is wrong with this code. Okay, and as I mentioned earlier as well, basically you need to check your code for boundaries, right? So basically check your code for boundaries. If there are if else's, if there are other boundaries that are given by the constraints, right? So basically check around the code for the boundaries, and then you might find the solution, right? And for those who just want to enjoy the show, here it is. So what is happening in the code is that basically n and k are given to us with 10 to the power 9, and t is given to us 10 to the power 5. So t is fine because we are storing 2 into 10 to the power 5, that is fine. But n and k are 10 to the power 9. So if you look at this line number 20, right? In this line, basically what we are trying to do is we are trying to multiply n and k, which are 10 to the power 9. Okay, and since this is integer, so basically the value that n and k can take, n multiplied by k can take, is 10 to the power 18. That is very large, and that can cause an integer overflow. Okay, and then basically we are dividing it by GCD of n comma k. So GCD of n comma k is not going to cause any integer overflow. Why? Because we are using a mod b and b operations, which is fine. So it's not going to give us any integer overflow values, but this LCM here might give us. So n times k multiplying might give us. So what we can do is we can just use unsigned long, okay, for this as well. So here basically when we are trying to multiply n and k, it is still going to give us integer overflow because GCD is integer. So so basically we need to tell that basically convert this GCD integer to unsigned long k. So the final output is unsigned long. So basically what we can do is we can just type it unsigned long. So the GCD of n comma k will also be converted into unsigned long, and then basically it will be divided by n times k. So whatever the LCM that we would get it correct, and then basically we will divide it by k, right? So now let's submit it. And this is the correct answer, right? So the issue was that basically the code that we wrote in integers caused an overflow, due to which we were getting wrong answers. So this is a new domain now. Okay, so as you can see, this problem is 1532. Okay, although the problem was simple enough in terms of its concept, like we needed to find the LCM of n and k, right? And you could Google it out that basically what is the best way to find the LCM, and you would eventually reach to Euclid's GCD algorithm. But the problem was not that simple. Okay, the problem gave you the constraints, and the constraints needed to be handled properly, because when you are calculating GCD, when you are calculating n times k, you need to think about it whether you are going out of range errors or not. So basically whether your integers are overflowing or not. So this is one of the great problem. Okay, and the time complexity, as you can see with GCD, this is log n. So we have solved TLE, we have solved wrong answer, and now we have the final solution. Okay, so with that I'm going to take a break. So we'll see you after the break. Thank you.